Okay, last time this is what we were looking at, and we looked at convergent sequences in which the numbers approach a certain value, and divergent sequences in which the numbers, well, goes towards infinity, all right? And it keeps taking a larger and larger towards infinite value. Let us look at some more examples of sequences. Let me erase the board here and look at some more examples of sequence. Now, before we look at them, just one thing. Remember, even if you have infinity divided by infinity, the limit does not exist. It is not equal to 1. Even though if you have 1,000,000 divided by 1,000,000, this is equal to 1. But if you say infinity over infinity, it does not equal to 1. The limit does not exist in this case, right? So, if you say you want to find the limit as x tends to 0 of 5x divided by 10x, right? Or, well, this would cancel down to x over half x. So let me write it as that. As x divided by, or x over 2x, I should say. X divided by 2x. As x, no, I said 10 to 0, it should be 10 to infinity. It's infinity that I want. As x tends to infinity. Let me rewrite this part. I want it to look neater than this. As x tends to infinity. Good, good. The thing is, you're going to have infinity divided by infinity. And the limit does not exist in this case. Even though you have 1 infinity over 2 infinity, what is infinity? It's not a fixed number. So the limit doesn't exist. Another thing that I want to say is if you have, let's do it under here. If you have a number divided by 0, the limit does not exist. This is undefined. This cannot work, right? You cannot divide by 0, right? You can't divide by 0 in that case. Now, if you, for example, have the limit as x tends to 0 now, as x tends to 0 of 1 divided by x, the limit doesn't exist, right? Because you have 1, say x was 1, and then in the next case x is half, 1 over half, and you have 1 over quarter, right? And you have 1 over 1/8. This is 1, this is 2, this is 4, this is 8, and the number keeps going up and up and up. So this can't work. If x is getting smaller and smaller, you have a fixed number, in this case 1, divided by a variable getting smaller and smaller. The answer will get bigger and bigger. So the limit of this doesn't exist. So you can't work with this. Alright? Now, let's look at a few examples in which we are given a function and are asked, what is the limit, if it exists, what is the limit of this particular function? Suppose we have the limit as x tends to infinity of, not n, x plus 1 divided by x plus 2. Well, now, it seems as if as x tends to infinity, we would have infinity plus 1 over infinity plus 2, which in this case the limit would not exist, right? Well, let's see if we can approach this in another way. Let's find some way, some mathematical manipulation of this function. Right? See if we can rewrite it in another way. This I want to continue writing it in white. X plus 1. Suppose we divide both the numerator and denominator by x. Remember, each term would be divided by x. It's the same thing as multiplying by 1 over x. So if we multiply this by 1 over x and we multiply this by 1 over x, what would happen? We would have x divided by x multiplied by 1 over x. It's the same as x divided by x plus 1 times 1 over x is the same as 1 over x. Alright? So that's this part. X, 1 over x times x would be x over x. 1 over x times 1 is 1 over x. 1 over x multiplied by x is just x over x plus 2 times 1 over x will be 2 over x. What would that mean in this case? Let's see. X divided by x is just 1 plus 1 divided by x all over, and then this is 1 divided by x is 1 plus 2 divided by x. Now, in this case, what we have, x, what did I write here? I didn't write the infinity. X tends to infinity. I should have written it. Didn't realize that I didn't write it. X is tending towards infinity. Now, let's rewrite it down here and see what would happen. The limit as x tends to infinity of 1 plus 1 over x divided by 1 plus 2 over x equal. Now, what happens to 1 over x as x tends to infinity? The limit as this tends to infinity is 0. You see that? The 1 will remain untouched. So it's 1 plus 0 divided by. What happens to this? And let me backtrack a bit. Remember, when you have this expression here, the limit of 1 plus 1 over x over 1 plus 2 over x, what you're really finding, is the limit of 1 plus the limit of 1 over x divided by the limit of 1 plus the limit of 2 over x. It applies to each of them independently. That's why I was able to write 1 plus 1 over x and so on a while ago. Now, the limit of 1, it is x that's tending to infinity, not 1. So 1 remains as it is. Nothing happens to the 1. But there's an x here now. So, and remember, I had left off the x tend to infinity because I didn't want to crowd it too much with too many writing. But each of this limit is as x tend to infinity. Alright? I just left it off. 1 plus, when you have 1 over x as x tend to infinity, x is getting bigger and bigger. 1 over that is getting smaller and smaller, so it's 10 to 0 divided by the limit of 1 as x tends to infinity is just 1 plus, what about 2 divided by x? The limit as x tends to infinity of 2 over x. Now, the board is becoming a bit crowded. Let me erase some of these things. Alright. Alright, good. Too crowded and distracting. Now here, 2 divided by x. When you have 2 over x and x keeps getting bigger and bigger, 2 over a number that's getting bigger, the answer will be smaller and smaller, so it approaches 0. So here now, what you have is really 1 over 1, which is 1. So the limit of this does exist, and it is 1. It's just a matter of doing something to rewrite the function in a different way to make it clear. Alright? So rewrite the function so that you have a number over x, or it could be that you have x in the denominator. And then what you have in that case is a number divided by a number, which is in this case 1. So we found the limit of this, and the limit of this equals 1. We'll look at another example next time.